we talked about it so far. So, so I have this data here. I construct my model. So within my model, I have this parameter theta. So now is unknown. I need to determine the values theta. So in order to do that, I construct my loss function. So for linear regression, I'm using this MSE. This is one choice of the loss function. So we're going to talk about their other loss functions of that. So next step will be learning step. In this step here, I try to find my optimal parameter theta. And right now, I'm going to implement them through an iterative methodology, through the gradient descent methodology. And then because I know how to calculate my gradient here, and then I'm going to update my theta by using this updated step here. And then you can choose step size to be either a small number, or you optimize the step size at each iteration here. So what do I mean, optimize the step size? Well, so by this step here, you already calculate the direction there. You know what to do. And then what you can do here, you can search over all the choice of step size, identify the one that reduces the overall loss function most, right? Because alpha here is a single number. You can try a few numbers, right? You can increasing the values of alpha or decrease them. And if you can find the direction that step size that decreases your loss function most, and then you can choose that step size. So this is called a search methodology. You can search the best one. And so of course, if you search over all choice of parameter alpha, so that is going to be take a bit of long time. And then people will say, well, let's do something simpler. Let's reduce alpha. Start with a relatively large number, and then reduce alpha at each step of that by exponential, by reduce them, cut them in half, right? For instance, and then you check, you verify if you are reducing the loss function or not, right? So, and that's another step of kind of find the optimal direction of the alpha by start with a large number and reduce the values of alpha with certain polynomial terms of that. And then you can guarantee that after you're reducing alpha to be sufficiently small, you always kind of find the direction will reduce your loss function. So that's another way for doing that. So in practice, people tend to either keep alpha to be a constant, choose a relatively small number, and then don't change it. For instance, you choose alpha to be 0.01 and stay this way. And so that will reduce your overhead of determining the step size. Or you have some fixed scheduling procedure. For instance, you might say, after some iterations here, I reduce alpha to be by half, to be or 50% or 20% or 80% of that. But you schedule it with a fixed scheme. So that's another common way for determining the step size of that. But in terms of the entire implementations here, the delta theta is a harder step. Alpha is relatively easier step to determine. Okay, it's just called a step size. But after you're doing this, or implement them, and you will be able to identify the optimal parameter theta. So that's one way of solving the linear regression is through this type of iterative methodology. However,